Hi everyone, the following is a video tutorial for the Wheel and Axle Simple Machines Lab in Onshape. Step 1, of course, is to log into the Glenbrook South Enterprise. Once logged in, navigate over to the Documents tab. And in your team folder for your class, whether it's Gold 3, Gold 4, Blue 1, or Blue 2, in that team folder, you should see a folder for this particular lab, Wheel and Axle. Click on that folder. This is going to be your start file. Right click here to make a copy the workspace. And just like we did last time, please remove the dash and the word copy on the back end, and then type in your full name on the front end with a space and a dash. And please leave the title of the activity the same as it is. Once you have that, say OK, and it'll take a moment to populate. With this activity, we're going to set up two separate wheel and axle systems. We're going to evaluate what happens when you have a larger wheel driving a smaller axle and a larger axle driving a smaller wheel, or vice versa. So in this file, the tabs across the bottom, the first one starting with the assembly, has all the parts laid out just like we had with our last lab. So I have the 4 different gear sizes. This is a 12 tooth gear. We have a 36 tooth gear, a 60 tooth gear, and an 80 tooth gear, 84, excuse me. And then we'll have 2 of these side supports, 2 of these C channels that we'll use as side supports. I have bearing flats here that we can insert on those C channels for the axle shaft. And then what we'll do is very similar to the last lab. We'll get one of these support systems set up here on the left side of our base plate, and then we'll do a linear pattern, copy that over, and just attach the gears to it and our arrows. On the second tab, I have a drawing sheet, and this is going to be a little different than what we did last time. I wanted to incorporate some type of questions relating to the assemblies that we were building here for our simple machine examples. And so for the wheel and axle one, I'm going to ask you guys 2 different questions. The first one is, what is the IMA for the wheel and axle on the right? So where I said we're going to have 2 different setups here. So on the right, identify where the resistance is and where the effort is applied. So red is resistance, green is effort. And using that information and the diameters provided here for each one of these gear sizes, calculate the ideal mechanical advantage. You'll just do the same thing there for the wheel and axle on the left. Note that here on the right, we have a smaller gear going to a bigger one, and that's for the effort and the resistance. And then for effort and resistance here, we're going from a bigger to smaller. So what you will find is that one of these IMAs will be greater than 1, and one of them will be less than 1. So that's just a bit of for a hint there on the worksheet. All right, so back to the assembly. And then also, I guess, on the drawing sheet, it gives you a finished look at what the assembly should look like when it's all said and done, which also could be helpful for you folks. So for the assembly, what I want to do is get these C channels mounted to the faceplate here, this base plate, and somewhere on the left-hand side, just so I have enough room on the right-hand side for them. And if you notice on these C channels, there's one side that's cut nice and clean, and on the other end, it's kind of right through one of these little holes that they have there, which is kind of typical of some of the parts that you might find in the makerspace. A lot of them end up being cut down from longer portions of C channels, and so for today's activity, it would actually be a lot easier if we made sure that this flattened side was against the base plate. This makes your constraints a little bit easier to work through. So first constraint is going to be a fastened mate. If I hover my mouse over this flattened edge here, either one of these points would do, not a real big deal which one you select. I'll just grab the inside one and then just zoom out and pan over to the bottom side over here, and I'll try to put it right down the center. So again, any one of these points is going to be just fine. It's not a big deal as long as you have enough space. So I'm going to make sure that that symbol is flat against that metal piece. Select the edge here. It brought that part over for me. I just want to flip it so that the C channel is facing upright. And that looks perfect. So I'm going to go ahead and hit the check mark. From there, I'll grab my next C channel, do another fastened mate, I'm going to grab the same point that I did on the other one, so the inside edge. And then if I go back down here, I'm going to rotate my assembly. And you don't need a great deal of distance between the two ends because you're going to be mounting the gears to the outside. So I'm going to go 1, 2, 3, 4, 5 rows. And I will again pick that same outside point right here. So you can see it has the C channel underneath. So I'll just hit the flip button, brings it right back up. It's rotated perfectly. It's right where I want it. Okay, so now I'm going to go ahead and bring in those bearing flats, because we had talked about last time how if we were building these in real life, you have a square axle shaft inside of a square hole, doesn't really rotate that well. So we're going to convert that over into a rounded hole using the bearing flat. So with a fastened constraint, it's going to go for the top middle hole here, grab the center of this, and then on the bearing flat, grab the back side center of one of those holes. Zoom over and see where it put it. I do want the bearing flat on this side of the C channel, so I will just hit the flip button here, and that looks perfect to me. Hit the check mark. Then I'll do one more of these on the other side. If I just rotate to this side of that bearing flat, grab that same top center hole, and then here on my C channel, top hole in the middle row, it's on the other side, so I'll flip it, and now I just need to rotate it. So I'm going to offset, rotate around the Z axis 180 degrees. Okay, looking good. Now I can insert my shaft with a revolute constraint, and then that's the part that we're actually going to just pattern over, so we have two examples to work with. So revolute constraint, I'm going to grab the end point here on the axle shaft, center end point, and then here I'm going to grab the center hole, and we can put it in any one of these really. Typically speaking, you might have like a screw here and a screw on the bottom and then use the center hole, but it really doesn't matter. For now, I'll just go ahead and select the top one here. And then we'll just have to play around with this value a little bit for offset so that we have enough of the axle shaft hanging on both sides to insert the gears onto. So with offset in the Z direction, if I type in 1 inch, it is a 4-inch shaft. That moves it way too much. We're just going to go with a 0.5. Looks like it's a little heavy to the right still, so 0.75. And a little heavy to the left, so split the difference, 0.65. Looks just about right. There should be enough space to fit the gears on there and not really have anything intersecting with itself. So I'll hit green check mark there. And again, the numbers that you folks use are not terribly important to get exactly the way that I have it. As long as you have 2 C channels with some bearing flats on there and an axle shaft through it with enough space, you're going to be fine moving forward. But at this point, what I'll do is linear pattern this over. So I have 2 of them and then just attach our gears. So linear pattern, we did this on our previous lab. You want to select all the parts that you want to move. So 1, 2, 3, 4, and then 5. Select the direction option over here. And then just like we did last time, I'm just going to use the base plate. One line in this direction would be fine just to set the direction. For instance count, I want 2, and then just work on creating some separation between those examples. Let's see here. 6 is fine. I'll go 7. That looks good too. So 7 inches of space between them. This looks perfect. If I try to rotate one axle, the other axle should rotate as well. That way, when you go to create your animation and record your video, it's just one of these constraints that you have to animate, and then everything is moving. Okay, and so the next step is going to be to put these gears onto our assemblies. And I'd like you to put them in the exact same pairings that I have here on the drawing sheet. So the first one is that 36 tooth gear, and we're going to put that with the 84 tooth gear in our first example. So So that would be this gear here on the left and the 84 on the right. And then in our other example, we're going to have that 60 tooth gear paired with the 12 tooth. So the 60 tooth gear right here and the 12 on that end. Okay, so I'm going to pull up a fastened mate and get those attached. Just going to grab the center here on the gear, attach it to the center here, right onto the axle shaft. Just rotate, have just enough room between there. So that works out. Hit the green check mark to put it in place. Then I'll attach this gear, our 84 with a fastened mate. Grab the center. If I can get it from this angle, looks like I can. Perfect. Grab the center endpoint on the axle shaft. Zoom out, make sure we're not glitching through. Again, there's enough space there. That looks good. Green check mark to finish it. Want to check it if we can. Try to rotate one of those gears. Works perfectly. Now we just have to get these other two attached. So same process, fastened mate. Grab the outside center of the gear and attach that to the center endpoint on the axle shaft. Go, check mark, move to the other side. Do the same thing, repeat the process one last time. Grab the center, grab the center. Perfect. Check mark in place. So we got all the gears attached now. They all rotate in unison, which is perfect. And then for the force arrows, we're going to do resistance, effort, effort. So red, green, starting on the left. And then also, I just put those arrows facing in different directions. So red is going down, green is going up. So I'm going to grab fastened mate, grab the very tip of the red arrow here, our resistance force indicator. Maybe just grab the outside edge here. I realized I didn't leave myself enough room for my arrow. I probably should have scooted it over a little bit. So it is going to interfere with that C channel, but I can move that. It's no big deal. Hit the green check mark. So I'm actually going to move that right now as a part of the tutorial. I'll show you guys how to go back and edit some of these things. So the very first constraint I have here was that C channel and where I put it on that metal plate. And so if I need a little extra room, I could just go back and edit this with an offset value in the Y direction, it looks like 1 inch. See what that does. I want to send it in the other direction, so -1 inch. Move that part over. Let me hit my green check mark. Everything should update here. And it just looks like I might have to go through and offset the rest of my C channels. So fastened mate number 2, I'll do the same thing in the Y direction. -1 inch. Apparently this one wants to go positive. So you just have to play that game sometimes, positive, negative, which direction does it need to go? And that actually worked out perfectly then. So you just had to move those 2 C channels. Looks like I have enough room here now to place the rest of my force indicators. Let me grab one of these green ones. I'm going to grab center point underneath here and attach that to the middle row right underneath my big gear. Like so. Check mark. And then we'll do the same thing for red and green. You could, if you want, just do a linear pattern, but this doesn't take too much effort. So I'll just do this again manually. Grab the tip, put it inside the hole here. Doesn't really matter where you click as long as it gets put there. And then I will do the green arrow on the other side. So grabbing from the bottom, find the center, rotate, put it here. There we go. And that is the completed assembly for this tutorial. So once you get this all built out, you can go ahead and record your animation. So that would be based off of this 1 revolute constraint. Go to animate, You could do 0 to 360 degrees. For this one, I would suggest you animating it as a loop. That way it's not just rotating back and forth, but it would continuously rotate in that one direction. And I'll speed it up a little bit by taking it down to 150 steps. So as I play that, you can see these gears all rotating at the same time. This will be what you want to record for the submission video, and just talk to us about the steps that you took to get to your end goal. And as a part of your video, don't forget that drawing sheet here on the second tab. So now that you've completed this assembly, I'd like for you to take a moment to try to answer these two questions. And for your response, you can use a note, which is right up here. If you click on this letter A, you can drop a note in here right next to the question, and then type in whatever that response would be. 1 to 1. Make sure you write it as a ratio, since it is a mechanical advantage. But I did say before, because of the comparison of the sizing of the gears, you will have one IMA that is greater than 1 and one IMA that is less than 1. You'll just insert the note right there, talk about it in the video, and that will be it for this lab. So hopefully by this point, you folks are getting the hang of this. So that is the end of the tutorial. That's all for now. Thanks for joining me. See you next time.